Hello everyone, this is Manish from Skillable India, and in today's session of geometric dimensioning and tolerancing, we are going to understand the resultant condition. Okay, so in the previous session, we have already understood about the boundary conditions. Okay, what is inner boundary, what is outer boundary, what is virtual condition, and in this session, we are going to understand in very detailed manner about the resultant condition. Okay, so when to use this resultant condition in geometric dimensioning and tolerancing, we will be discussing this in this session. So I am going to explain how to calculate the resultant condition. Okay, so by definition, resultant condition, if I will for internal feature and external feature, if I will be discussing this. Okay, so for a internal feature of size, the resultant condition is the variable value and the outermost boundary. Okay, in the case of internal feature, or hole, in this case, the resultant condition is the variable value, okay, and the outermost boundary. For external feature, in case of shaft or pin, the resultant condition is the variable value and the innermost boundary. Okay, so this is the case. In this case, okay, so this is the example of hole and this is the example of shaft. Okay, so in this case we will understand first of all that we have for hole we have the maximum material condition and the least material condition. Okay, in this case also we have the least material. In case of shaft we have least material condition 40.1 dia and the maximum material condition dia 40.5. okay, now one thing we have to understand that when we are seeing that MMC, okay, so when we have 40.5 in case of hole, first of all we are understanding for hole. Okay, so for hole, when at maximum material condition at 40.1 mm, the geometric tolerance what we have is 0.1 mm. Okay, 0.1 mm at maximum material condition. But as we move from maximum material condition towards least material condition, okay, from maximum material condition to least material condition, we get the bonus tolerance. Okay, so in this case, as we move towards the least material condition, if this is 40.2, then we have the 0.2 mm. Okay, when we have 40.3, we have 0.3 mm. Okay, at 40.4, we have dia for 0.4 mm, and at least material condition, which is 40.5, we have maximum tolerance, which is 0.5. okay, so 0.5 is the maximum tolerance we have. So at tolerance zone at least material condition for this hole, we have 0.5 mm. okay, so this is for the hole. Okay, in this case, when we move towards the maximum material condition to least material condition, at least material condition, when we have hole size is of 40.5 mm, so the tolerance zone we have is of 0.5 mm. Okay, so this is the case of hole. In case of shaft, now we will understand all the things with the shaft variation, with the example of shaft in this case. Okay, so for shaft, first of all we will understand, or pin, at maximum material condition, because we have maximum material condition modifier in the feature control frame over here. In this case also we have maximum material condition modifier in the feature control frame. Okay, so at maximum material condition at MMC, which is dia 40.5, we have tolerance zone of dia 0.1 mm. As we go from maximum material condition towards least material condition, which is dia 40.1, okay, so at 40.4 we have dia 0.2 mm tolerance. Dia 40.3 we have 0.3 mm of tolerance. Okay, dia 40.2 we have 0.4 mm of tolerance. Okay, And at last, at least material condition, which is dia 40.1, we have maximum bonus with the bonus tolerance. We have this at least material condition. So at dia 40.1, which is the least material condition for the shaft, the tolerance zone at LMC is 0.5 mm. Okay, so tolerance zone at LMC is 0.5 mm in both the cases. Okay, so how we will calculate the resultant condition with the definition we will understand. So this is the example. In further session I will be discussing this in detailed manner. Okay, so what is resultant condition? Resultant condition is the single worst case boundary. Okay, in previously we have already understand virtual condition. It is the definition looks similar to the virtual condition, but in this case it is the single worst case boundary generated by the collective effect of the considered feature of size specified at LMC or MMC and the geometric tolerance value for that material condition. Okay, so as we have understood that there are four concepts for the resultant condition. Okay, so in this we have the maximum material concept for the internal feature of size. Okay, so MMC concept for the internal feature of size for hole, LMC concept for internal feature of size hole, MMC concept for the external feature of size pin or shaft, and the LMC concept for external feature of size pin. Okay, so for both the cases we will understand these concepts one by one. So the definition is very similar, but they are two different entities. Virtual condition is different entity and resultant condition is different entity. To understand resultant condition better, we will take different examples. Okay, so this is the similar example of hole. So this is for the MMC concept for internal feature of size hole. Okay, so we will understand first of all we will understand the this is the for hole, the maximum material condition is dia 40.5 and least material condition is dia 40.5 and maximum material condition is 40.1. Okay, so when the tolerance zone is specified in the feature control frame is at maximum material condition. Okay, so if we see dia 40.1, which is MMC, the tolerance we have is 0.1. Okay, now as we move MMC towards LMC, LMC condition over here dia 40.5 is the LMC and we have the tolerance over here is 0.5 mm. Okay, so at LMC 40.5 we have the tolerance of 0.5 with the bonus tolerance. Okay, so in this case at the least material condition we will make the center which is having a tolerance zone of 0.5 at LMC. Okay, so tolerance zone at MMC we will take, which is 0.5, and the LMC, this is the LMC 40.5, the tolerance zone is for 0.5. Okay, so if we, in this case we take the extreme conditions, these are the extreme conditions. Okay, so these are the extreme conditions. We the holes, the tolerance. Okay, so in this case you can see that the tolerance zone is the, if this is a hole. Okay, so in this hole the maximum outer diameter, outer boundary will be the resultant condition. Okay, so in this case you will see that resultant condition will be this green line, outer boundary. Okay, so resultant condition will be outer boundary, which is 41. Okay, because 40.5 plus 0.5 will be 41. Okay, so if we want to calculate the resultant condition, okay, so this is the formula for outer boundary. LMC is 40.5, geometric tolerance value which is 0.1 in this feature control frame, and plus bonus tolerance. So bonus tolerance over here is 0.4 mm. Okay, so which is dia 41. Okay, so this is the resultant condition for the MMC concept for the internal feature of size hole. Okay, so in this condition, if we are talking about hole outermost boundary, so again the concept come of the envelope principle. Okay, so this is the actual minimum material envelope in this case. Okay, because it is the outer boundary of the hole. This is the maximum resultant condition the hole can be manufactured. Okay, now one of the cases. Okay, so in this example we have a position when the part is produced at LMC. Okay, so initial situation is to have a hole of 40.5. Okay, dia exactly at the center, which is practically difficult to manufacture. Okay, exactly at center, anything, it is very difficult to manufacture. Okay, so similarly we have the internal feature of size for hole. Okay, so this is the LMC concept for internal feature of size, which is hole. Okay, so when the hole is produced at maximum material condition, we get the bonus tolerance of 0.4 mm. Okay, in this case also we have a for hole we have the least material condition and the maximum material condition. Okay, so this is MMC and this is LMC. Okay, so we are talking about LMC. So at LMC dia 40.5 we have the tolerance of 0.1 mm. Okay, so as we move to LMC towards MMC, which is dia 40.1, we have the tolerance of 0.5 mm. Okay, so in this case 0.5 is with the bonus tolerance, 0.4 mm is the bonus tolerance plus 0.1, so it will become 0.5. Okay, so when the hole is produced at the maximum material condition, okay, so this is the condition of MMC. So when the hole is produced at maximum material condition, we have tolerance zone at MMC is 0.5 mm. Okay, so this center exactly, which is manufactured, which is very difficult to manufacture at real center. Okay, so we are taking the extreme conditions if the hole is manufactured at the extreme condition of this dia 0.5. Okay, so at this point, this point and this point, so we are taking 4 extreme conditions. Okay, so after manufacturing all the holes, you will see at maximum material condition the tolerance zone or at MMC will be, the tolerance zone at MMC is the tolerance zone at maximum material condition, which is dia 40.5, is geometric tolerance value plus bonus tolerance. So 0.1 plus 0.4 is 0.5 mm. Okay, so at dia 40.1 we have tolerance zone of 0.5 mm. Again, in this case you will see that the resultant condition is equal to the inner boundary. Okay, so this is the green circle you will see inside this green circle. So in this resultant condition is the inner boundary. Okay, so inner boundary is equal to the maximum material condition minus geometric tolerance value minus bonus tolerance. So in this case 40.1 is the maximum material condition minus 0.1 geometric tolerance value, which is given in the feature control frame, and 0.4 mm is the bonus tolerance, okay, which we have already calculated. Okay, so this is how if we reach at 39.6. okay, so the inner boundary, so resultant condition is equal to the inner boundary of the hole. Okay, so this is the minimum size of the hole, maximum size of the shaft that can enter into this hole in this case. Okay, so this is the LMC concept for internal feature of size for hole. Now we will understand the MMC concept for external feature of size. Okay, so in this case, so here we have a maximum material condition. Okay, so MMC concept. Okay, so we are having in a feature control frame maximum material condition modifier. Okay, in this case, this is the in case of shaft. So this is the case of shaft or the external feature of size. So external feature of MMC, maximum material condition, will be the 40.5 and 40.1 will be the LMC. Okay, if the it is manufactured at least material condition. Okay, if the shaft is manufactured at least material condition, so least material condition of the shaft is dia 40.1. Okay, so at that time, what will be the tolerance zone? Tolerance zone at LMC will be the geometric tolerance value plus bonus tolerance. In this case, 0. plus 0.4, 0.5 mm. Okay, so 0.5 mm dia of tolerance we are having at LMC, dia 40.1 mm of shaft. Okay, so now if we calculate, so this is the least material condition and we have the tolerance zone at least material condition is of 0.5 mm. Okay, now if we take the extreme conditions, so after creating the condition, you will see the inner boundary. Okay, so in this case, MMC concept for external feature of size. Okay, for shaft, MMC concept for shaft will be the inner boundary. Okay, so inner boundary in this case will be the actual minimum material envelope. Okay, so how we calculate the resultant condition is equal to the inner boundary is equal to the LMC, which is 40.1, minus geometric tolerance value, which is 0.1, minus bonus tolerance, which is 0.4. So we get dia 39.6 mm. So this is the inner boundary or the resultant condition at MMC concept for external feature of size shaft. Okay. Similarly, we take the LMC concept, resultant condition, not the virtual condition. It is raw resultant condition we are calculating. So LMC concept for the external feature of size shaft. Okay. So now we will calculate LMC. So in this case also MMC will be this and LMC will be this. Okay, so at least material condition we are seeing what you want to find after MMC for the shaft, which is dia 40.5, the tolerance zone at MMC will be 0.5 mm. Okay, so tolerance zone at MMC, which is dia 40.5, is equal to the geometric tolerance value 0.1 plus 0.4 bonus tolerance. We get the 0.5 mm. Okay, now in this case also, so this is the maximum material condition for the shaft and we have the maximum material condition, we have tolerance zone of 0.5 mm. So after extreme conditions, in this case you will see this is the outermost boundary. Okay, so this is outer boundary, which is resultant condition is equal to, in this case, resultant condition is equal to outer boundary. Okay, which is equal to maximum material condition, which is dia 40.5, geometric tolerance value 0.1, bonus tolerance 0.4 is equal to dia 41. Okay, so in this case dia 41 is the resultant condition and this is the actual mating envelope. Okay, so actual mating envelope. So this is the maximum size the part can this is the maximum size that the hole can enter into this actual mating part. Okay, actual mating envelope. So these are the formulas which we have already discussed. These are the 4 conditions. Okay, so specified at MMC, internal feature of size, external feature of size. So these are the formulas which everyone should remember for the resultant condition. For internal feature of size at MMC is the outer boundary, which is LMC plus geometric tolerance value plus bonus tolerance. Okay, and similarly for the external feature of size, we have formula the LMC minus geometric tolerance value minus bonus tolerance, which is equal to the inner boundary. Okay, and similarly for the specified at LMC for internal feature of size and external feature of size. Okay, so this is the very important terminology which we regularly use in geometric dimensioning and tolerancing, and then how we calculate the resultant condition is very important. Okay, so this is all for today's session of resultant condition. Okay. In the next session, we will discuss the different topic of geometric dimensioning and tolerancing. Thank you. Thank you, everyone.